Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, an attack that never tries to take your service down. It just quietly bankrupts you while everything stays online.
That's a creepy framing. Set it up. What's the actual scenario?
You build a product on a hosted LLM API. Every token your users send, and every token the model generates, lands on your bill. The classic attack? Denial of service. Tries to crash your servers. This new one, denial of wallet, doesn't bother. It keeps firing expensive requests until your cloud bill hits 5 figures and your card declines. The service stays up. The company goes down.
And the reason this is special to LLMs. Let me guess. Is that not all requests cost the same?
That's the whole crux. With a normal API, every request costs roughly the same, so you can reason 100 a minute is safe. With an LLM, one request can cost 100 times another. A 200 token chat message and a 120,000 token document summary are both one request. But the document costs 2 or 3 orders of magnitude more.
So the dangerous sentence is, I already limit to 60 requests a minute. I'm fine.
And it's flat wrong. Picture 60 max context requests a minute at a frontier model. That's roughly $2 to $5 each, which works out to over $7,000 an hour. Limiting requests is necessary but nowhere near sufficient. You have to limit 3 things: requests, tokens, and dollars.
Okay, let's get into the mechanism. How do you actually enforce a rate without a clunky background timer ticking?
The standard tool is the token bucket. And confusingly, the tokens here are capacity units. Nothing to do with LLM tokens. Picture a literal bucket. It holds up to some capacity, call it C. It refills at a steady rate, a units per second. Every request drains some units. If there aren't enough in the bucket, you reject it.
And the no timer trick is what exactly?
You only ever check the bucket when a request shows up. So you just compute how much would have dripped in since the last check. The level is the minimum of the capacity, and whatever was there plus rate times the seconds elapsed. No daemon, no ticking. The math does the refilling lazily.
Give me a concrete feel for it. What does that mean for a real client?
Say capacity 60, refill 1 per second. A client that's been idle 30 seconds shows up with 30 units waiting. So it can fire a burst, then it's throttled to 1 a second after that. A client hammering from the very start burns the bucket dry instantly and then gets exactly 1 request per second. So you allow short bursts but cap the sustained rate. That burst allowance is exactly why people prefer it.
Now I've seen people skip the bucket and just count requests per minute in a window. What's wrong with that?
The fixed window counter. It's simple and fast, and it has one nasty flaw. The boundary burst. Your limit is 100 a minute. An attacker sends 100 requests at 14:07 and 59 seconds. All pass, that Windows counter hits 100. Then 100 more at 14:00 hit and 1 second. Brand new window. Counter resets. All pass.
Wait, so that's 200 requests in about 3 seconds, even though the limit was 100 a minute.
Exactly double your limit. Right at every window edge. The fix is a sliding window. Instead of resetting on the clock, you track the rolling 60-second span continuously. Then any 60-second slice you look at never holds more than 100. The boundary trick just evaporates.
Okay, so even with a perfect rate limiter, you said requests alone aren't enough. How do you actually stop the wallet attack?
There's 5 of them, every one keyed per identity. First, a request per minute limit at the gateway for basic hygiene. Second, the real anti-wallet control, a tokens per minute budget, summing input plus output tokens, because tokens are dollars. Third, a hard max tokens cap on every single call.
Why both a per minute token budget and a per request cap? Feels like belt and suspenders.
Because they catch different failures. The max tokens cap is your per request firewall. It stops one prompt from generating a runaway multi-thousand token essay, even if your minute budget still has room. The minute budget stops the aggregate flood. Once a sniper, the others a dam.
And the last 2 layers?
Fourth, a daily dollar cap with alerts at 50, 80, and 100% of budget. Your financial circuit breaker. So if everything else fails, the bill stops and you get paged instead of surprised. And fifth, the one that makes the rest mean anything. Authentication. Require an API key on every request and key every limit to that identity.
Right. Because if you're rate limiting by IP address on an anonymous endpoint, that's trivially bypassed.
Spin up new addresses and you're past it. Limits without identity are theater. One more practical wrinkle worth knowing. For token budgeting, you can count input tokens before the call with a library, but output tokens you only know afterward. So you track a rolling spend and fold the last request's output into the next check.
So the one sentence I take away:
Denial of wallet makes you unprofitable, not unavailable. And the defense is cheap layers stacked per identity at the gateway. Skip any one of them, and the cost is a bill you discover at midnight.
limit tokens and dollars, not just requests. That's the Datarekha audio guide. See you in the next one.